So I will briefly repeat what the website on Cambridge in Color, or the web page on Cambridge in Color tells us about diffraction. Actually, a light ray will continue a straight path in normal circumstances. That is, when it is not passing next to a solid object, or if it is not interfered with a solid object. So when we work with a large aperture, almost all of the light rays will continue a straight path. Only the light rays that are passing just next to the aperture will be affected by diffraction and will show a slightly offset in their path. These light rays that happen to pass just next to the aperture blades, they form a very small minority of rays compared to all the rays that continue their correct path. So when working with large apertures, diffraction has in fact no influence on the images. So there's no image sharpness reduction when working with large apertures. However, when we work with a small aperture or a closed down aperture, and we consider that light rays going in the middle will not be affected by diffraction, but light rays passing just along the edge of the aperture will be affected and will kind of spread out behind the aperture, then the amount of light rays that does not continue in a straight way is comparably large compared to the light rays that do continue in a straight way. So this fraction of spread out light rays becomes significantly important compared to light rays that still go on straight through the optical path in the lens. So the smaller the aperture, the more light rays that will be affected due to diffraction compared to light rays that will not be affected. And then comes into account the pixel density of your sensor. So if you have a smaller aperture, and I will draw it even more small, and there are quite some rays that are affected by diffraction, then you must look at your sensor density to know when and how much diffraction will influence the quality of your image. So if you have a sensor with very little pixels, of course this is not a realistic drawing that I'm making here, but it's just to show you how pixel density will influence the effect of diffraction. So if you have a sensor with only very little pixels, actually diffraction will not affect pixels that are next to the one that is actually capturing the light ray that is following the right path. However, if you would have a sensor with a high pixel density, so pixels very close next to one another, as I draw it here, it is of course obvious that when a light ray or light ray is coming from the same subject and being influenced by diffraction, they all should arrive here on this pixel. But as we see with diffraction, they come in a wider array towards the sensor, and they start influencing adjacent pixels with a part of spread out light. So the denser your pixels are on your sensor, the more diffraction will become a problem. That is what we will find out in the next part of this workshop, being the practical test for your proper camera.